The nerds are back, eh? Let's go for number 3. Let's enjoy it. Okay, so here we have the third type and the fourth type. We're all going to cover them both in here because the third type has not been coming. Because power series has been coming, but it's not coming this time. So let's quickly talk about it. Here's the second. You have the second derivative. I don't want us to waste time. Okay, I don't want us to waste time on simple things. It is unacceptable. You're not going to do that, right? You're not going to waste time because in here you're going to hardly integrate. Come on, you can do it. Tell yourself that. Let's see. Let's go for it. So here we now have. Let me show you what the third type is going to be. It's going to have the second derivative. You see, the types you've been doing have no second derivative. Now we have the second derivative. And here you have the second derivative being equal to something here. This is the fourth and final one that's coming. But we are going to first start with it being equal to 0. And that will be called a homogeneous second order. So let's do that. Let's say we had it, say, d2y dx squared plus 3dy dx, right? Plus 2y is equal to 0. Let's say that's what we had it say. How would I solve this? Now, this is what we call a second order homogeneous differential equation. It has the second derivative. This is the first time you're seeing something like this. So what you're going to do is, here is the principle. The principle is that when we have a derivative with respect to x or whatever, we are going to call it d. And then when we have the second derivative, because we now need shortcuts, right? We're going to call it d squared, okay, with respect to x, okay? Then these y's, we are going to factor them out completely, including this one, right? So we're going to say this is going to be what? The second derivative, so it'll be d squared. Is only that. Plus here is 3 times the first derivative. So it's 3d plus 3d plus 2. Okay, don't put the y because the y's we are going to put them outside. This is going to be equal to 0. So we have rewritten it in this form. It is called the d operator form. That is what you do in step number 1 when you have it equal to 0. You rewrite it in d operator form. Now when you rewrite it in d operator form, you don't make anything the subject. Exactly as it is, you just change it to d operator form. Now when you change it to d operator form, what you'll be knowing is y cannot be 0. Y cannot be 0. So we are going to create an equation that can be 0. This inside can be 0. Okay, but then we're not going to solve it as d's. We're going to solve it as m's. And those m's will then help us to then come back and find the y. You understand? So we're going to create now what we call an auxiliary equation. What it is you take this inside, but you write it in terms of m. And you make it equal to 0 because these two things are multiplying to give you 0. So one of them is 0. And it's this thing. And we write it in terms of m to say m squared plus 3m plus 2 is equal to 0. Here we have created an equation and we solve it. We solve for m. Let's go ahead and let's solve for m. How am I going to solve for m? Always solve it using the quadratic formula. Okay, now the quadratic formula, you need to have 3 things. Your a, and your a is the number before m squared. In this case it's 1. Then your b is the number before m with its sign. In this case it's positive 3. Then c is the number that stands alone. In this case it's positive 2. Now once you have your a, b and c, you now start to apply the quadratic formula. The quadratic formula, in this case we are looking for m, so it would say m will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's what we're going to use to get m all the time. You understand? Now what are we going to get? First we get what we call this the discriminant. We get this thing inside the square root, which is b squared minus 4ac. So after you write your a, b and c, you're then going to say b squared minus 4ac. This is going to be, what's my b? 3. So it's 3 squared minus, you open bracket, you say 4 times a, 1 times c, 2. Okay, after your minus, you open your bracket, you put everything. So in this case it's going to be 3 squared 9 minus 4 times 1, 4 times 2, 8. So it's 9 minus 8, which is 1. So b squared minus 4ac is 1. Now we're going to say here m is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we're going to say m, in this case m will be equal to negative, what is our b? 3. So it's negative 3 plus or minus the square root of b squared minus 4ac. We got it as 1 all over 2a, which is 2 by 1. So we can now get our 2 values for m. M will be equal to minus 3 plus or minus the square root of 1 is just 1 all over 2. So we can now say here the first m will be equal to minus 3 plus 1 over 2, or we can have the other m as m is equal to minus 3 minus 1 over 2. Now we're going to get here our m being equal to minus 3 plus 1, that's negative 2 over 2, you'll be negative 1. You punch in the calculator, come on, that's your m. Then the other m will be minus 3 minus 1, you get minus 4 all over 2, you're going to get negative 2. This you punch in the calculator. Now the solutions you get for m tell you what to do on the next stage. That is big. Here is the next big thing you have to remember. Everybody has seen how the first stages are. Convert to d operator form, create auxiliary equations, solve. Okay, now the solutions you get for m are going to tell you what to do on the next stage. You are not done, because you solve for m, then you create an equation, then you look for the constants. So you have solved for m, now you have to create an equation. And here is what you got to remember. You need to remember this part. When you're creating an equation, right, when you are creating an equation, there are three situations that you're going to use, right? The first situation, case 1, is if you have m being a number, the m being nice numbers like minus 1 and minus 2. These are real numbers. So you have m being real numbers and being different numbers. So it's different real numbers, right? So we say the case 1 is when you have m being, the two values for m being distinct and real. Distinct means they are different and they are both real. Then that you are going to have your y being equal to a, then e to the m1x plus b, then e to the m2x. Your m1 is this first, your m2 is the second value for m. So it is a y will be this. This is going to be your equation. You have to remember this. You have to remember it. So a y will be a e to the m1x plus b e to the m2x. So your m1 and your m2 are just going to go to be powers. There will be powers here, okay? Powers of e. Do you understand? Are you hearing me? There will be the values you get for m1 and m2, you put them as the powers there. Then you look for a and b using your conditions. That is how you then look for a and b after having substituted your m1 and your m2. Now let's do the case 2, because in this situation we've seen that our answers for m were distinct and real. One was negative 1, the other one was negative 2. So we'll use this situation. But that's not the situation you always get. Okay, you can get m being the same number twice, so it can be repeated and real. Let's say you get m being 2 and 2 as well. So now how would I have y? Because the next stage will be to create the equation. What will be y now? When you have it like that, here is what your y will now be. For repeated and real, you are going to just have it like this. You're going to have ax plus b inside your bracket, then outside you have e to the mx, because both of them will have the same m, right? So you're going to write your equation in this form, then you substitute m, because you would have found the m is going to be that same value, because it's going to be the same value twice. So you then look for a and b. Afterwards, using the conditions, you then look for a and b using the conditions. Are you hearing me? Then the third case is if you get them being complex. Okay, so if you now get two complex solutions. So complex solutions, there are complex solutions and they are also distinct. There will be distinct complex. There will be two different solutions. Okay, now you are going to have a complex number. You get your solutions being, you have your two solutions being, now you get, let's say here, m1 will be equal to alpha plus, let's say we say beta 1 I. Okay, then you are going to have your m2 being alpha plus beta 2 I. So here they're going to have alpha, we say alpha minus beta 1 I. I'm sorry, what am I saying? So it's one will be plus, the other one will be minus. That's the only difference. So it'll be alpha plus beta I, and then the other one is going to be alpha plus thing. So what do you now do now when you are writing your solutions? Because you're going to get these two complex solutions. Alpha, which is a number, say 2 plus 3i. Okay, or you have 2 minus 3i. This is going to be the second solution. So these are the two solutions you'll have. One is alpha plus bi, the other one is alpha minus b1i. Okay, you're going to get it. So now what are you then going to do? Where will you put the thing? This real number here, Look closely. This is the last one. The real number is going to go to be your power of e, because it's no longer m now. Okay, it's going to be your power. So you're going to have your y being, y is going to be, you factor out e, so it'll be e to the what? Alpha x. Okay, it is e to the alpha x. Then you are now going to say a, which you're going to need to find, a cos beta plus b sine beta. Remember, it's beta 1. You can call it beta 1 or beta is going to be the same value, right? A cos beta plus b sine beta. So it's e to the alpha x. Remember, it will be having alpha and beta. Beta is the imaginary part. Alpha is the real number. Okay, this beta is the imaginary number because it's the number before I. Any complex number has two parts: real and imaginary. So you take the imaginary number, the number before I, then you take the real. So the real is going to come as your power. It's e to the real x plus a cos imaginary plus b sine imaginary inside, and this is going to be your y. So remember the y for these three cases. You have to remember it. You're not going to be given, and then you can now find. So in our situation, we got, let's go back to our situation. We got m1 to be -1, m2 to be -2. So now you're going to say now here, y is going to be equal to what? A, right? E to the m1x plus b e to the m2x, which is going to be y is equal to a e to the -1x, which is just -x because the m1 is -1, plus b e to the -2x because m2 is -2. We got -1 for m1 and -2 for m2. So we have them, we put them as our powers. Then we have now this as our general solution. Once we have our general solution, we can now go to these here, to these conditions, and we'll find your a and b. How? In here you have been told first that y0 is 0. Let's just say what it just means is going to be saying y, let's put the conditions, let's create them. I'm going to create the conditions how you'd normally see them. Okay, you're going to say y is equal to 0 when x is equal to 0. Okay, and then you can say y prime will be equal to 3 when x is equal to 0. Here are the two conditions. We've been told that y is 0 when x is 0, then y prime is 3 when x is 0. Okay, so in the first condition we're going to say let x be equal to 0 and y equal to 0, because we've been told y is 0 when x is 0. Now we are looking for the particular solution. So for y we are putting 0, for x we're putting 0. So 0 is equal to a e to the -0 plus b e to the -2 by 0. Okay, now any number to the power 0 is 1. So 0 is equal to a times 1 plus b times 1, because e to the power 0 will be 1. Any number to the power 0 is 1. So 0 will be equal to a plus b. Okay, and you're going to have a being equal to -b. There we have it. This is going to be our equation number 1, where we said a is equal to -b. Then now we need to find y prime, because the second thing is for y prime, which we don't have. We do not have. So we write our y again. Y was a e to the -x plus b e to the -2x. Now what we are then going to do is find our y prime. You're going to say y prime will be equal to what? You are differentiating, right? A never goes anywhere. Let's now differentiate e to the -x. It first comes back as it is e to the -x times, you then differentiate the power, which is -x. Derivative of -x is -1. So when you differentiate e to the -x, what happens? It comes back as it is, then you multiply by the derivative of that power, the derivative of -x, which is -1. Then you now say plus b is just a constant, it's not going anywhere. Let's now differentiate e to the -2x. It first comes back as it is, e to the -2x, it comes back as it is. Then you multiply by the derivative of that power. Derivative of -2x is just -2. You understand? Then now you have your y prime being equal to, here -1 is going to be negative a e to the -x, then -2 will be now -2 b e to the -2x. Here we have our y prime. They've told us that y prime is 3 when x is 0. So you're now going to say let x be equal to 0 and your y prime will be equal to 3, because that's the other condition. So you now put for y prime, you're putting 3. 3 is equal to -a e to the -0 minus 2be to the negative 2, 0. So here you're going to have 3 being equal to negative a by 1 minus 2b by 1, which is going to be 3 is equal to negative a minus 2b. Okay, but you have been told in equation 1 that a is negative b. So where there is a, we're now putting negative b. 3 will be equal to negative of a, which is negative b, then minus 2b. So now you're going to have 3 being equal to minus b is just b, minus 2b, and then b minus 2b is negative b. So 3 will be equal to negative b, which you divide both sides by minus 1. You're going to get negative 3 b equal to b. So what do I have? I know my b. B is equal to negative 3. I'm done. But you have in equation 1 said a is negative b. So you are now going to say, since you're going to say a is equal to negative b, so you have a being equal to negative of negative 3, and you have a be equal to 3. So here you have your b be negative 3, your a be 3. Are you done? No, you then rewrite your final equation. We had it as y is equal to a e to the negative x plus b e to the negative 2x. That's what we had. So you are now going to say y is equal to a is 3e to the negative x, then b is negative 3 e to the negative 2x. This is going to be our particular solution, and we are done. You get all your marks. This is how simple it is. Go ahead and butcher it. Okay, now let's do this one which we actually got, where it's not equal to 0 now. It'll be equal to something that's not 0. What changes? Small thing. Let's go ahead and let's do it in the next video. Goodbye for now.